Hello everyone, this is Jobin. Today I'm going to present a easy method to improve Wi-Fi signal strength in your laptop or the desktop. First of all, what are the factors which is affecting the signal strength? The distance between the router and the device. Second one is the obstacles between the devices. And third one is the interference. And fourth one is cage effect, or called Faraday's cage effect. And fifth one is antenna problems. What are the interference at this same spectrum? Bluetooth devices and other electrical equipments like microwave oven. It is protected from leakages, but still some leakage happens. And other Wi-Fi devices and routers. All these works in 2.4 gigahertz range, and it can cause interference with your Wi-Fi signals. And coming to the cage effect, or Faraday's cage effect, it says that there is no electric field inside a conductive cage or shield. So in reality, it can protect you from lightning or high voltages, electric fields outside. But in the adverse side, you may lose signals inside a cage, like elevators. And same thing happens in laptop or PC enclosures, which is built using metals. A common solution for addressing this is to use an extension cable, USB extension cable, with a Wi-Fi adapter. I have few of them with me. And here is analysis of a poor reception. As we can see in the screen, I am getting minus 75 dBm. And we need to understand anything beyond 67 dBm is considered as very poor. And 73 dBm is around 100 picowatts. For common man to understand the decibel, the dBm, we use a 3 and 10 rule method. For every 3 dBm increase, the signal strength doubles, or for 10 dBm, 10 times signal strength. It's a logarithmic scale, it's not linear. So if you open this Wi-Fi adapter, the inside will look like this. There is USB pins on the one side of the PCB, and the other side we can see a antenna. This is only one side of the antenna. This is how the PCB looks in the other side. There is portion of the antenna and there is balun. I am not going to the details of that antenna design, but this is how it looks. Yeah, coming to how we can design a better antenna. As we can see in the screen, this is a antenna which is embedded into the PCB. The purpose is to reduce the size, not to give the best signal strength. So there is a scope for designing a better antenna. To understand how to design a better antenna, we need to look at the wavelength of the electromagnetic waves, because the microwave is an electromagnetic wave. Its wavelength need to be considered for designing a better antenna. As we can see in the screen, the signal reaches the highest point in lambda by 4. That means the antenna should be of length of quarter the wavelength. So coming to the design, the calculations, the microwave is using frequency of 2.457 gigahertz as per the detection. And the wavelength calculation goes by the equation C by F. C is the speed of the light and F is the frequency. So the wavelength of 2.457 gigahertz is 12.2 centimeters. The quarter the wavelength is around 3.5 centimeters. And there are online calculators available in the net. You can search and it will help you to design the antenna in easy steps. So we need an antenna of 3 centimeters approximately. So the easiest method is to take a copper strip. It can be available from any of the thick wires. So I took one of such copper rod. It's not even 1 millimeter size, and its length should be 3 millimeters. But in this case, I have some extra space to solder, and this is how it appears after soldering. The balun is preserved, and the place where the signal reaches from this antenna as well as this antenna is a common point, and from this signal is taken for processing. The plastic cover of the Wi-Fi router can be drilled. A hole is made on the back so that we can keep the antenna outside the Wi-Fi adapter. It's very small. The picture it may look big, but it's only 3 centimeters length. So here is the results. After this modification, the signal's strength improved to 59 dBm. The same machine and the same network. And how this appears in the end result. Previously it was running thousands of milliseconds, but now it dropped to 10 to 15, around 15 milliseconds. Not more than 20 milliseconds. This is one of the best reception pattern. So the 75 to minus 59 dBm translates into 40 times gain. Your signal strength improved by 40 times. So the story is just use 3 centimeter copper strip and achieve 40 times gain. Thank you.